This video is going to cover the topic of probability simulation. Be sure the date and topic are at the top of the page. The essential question for this video is how can we design experiments to simulate probabilities that we can't test? Sometimes we want to test the experimental probabilities, but we don't have the means to do so. We have a lot of practice testing on spinners and dice, but in the real world, there are a lot of things that happen and we want to know about, but we can't reproduce. For example, how would you go about testing whether it's likely that 3 puppies born in one litter are all female? Right? To test that, we would need something to use in place of the puppies. We can't actually just on demand find that information. In doing so, we'll need to identify materials we can use to represent the different outcomes. Once we have those materials and outcomes represented, we'll have to figure out how we want to run the trial and how often we want to run the trial to get a sense of the probability. Luckily, we can use many of the same tools we have used for probability in the past. For example, we are very well familiar with spinners and dice and coins and marbles, and all of these could be set up to simulate or represent our test of, in this case, puppies. So here's our sort of example idea, right? What is the likelihood that 3 puppies will all be born female? So essentially we're looking for a female, followed by a female, followed by a female, right? Since there are 2 options for the puppies, male or female, we can use a fair coin. After all, a coin also has 2 outcomes, right? Heads or tails. So a heads or tails could represent the male or the female. And prior to running the experiment, we would decide what we want to represent which. So let's say we decide that if we flip a coin and it lands on heads, then that is simulating or representing the puppy being born female. So we've completed our first step, right? We made a representation. The second step is to run a trial. And in our trial, we would need to flip our coin 3 times to simulate the 3 different puppies being born. From there, we can record what the results were, right? Did we get a heads, heads, heads for 3 females? Did we get some heads, some tails for males and females? But we would record what we found. So for example, maybe you would record heads, tails, tails, knowing that that means there was a female, a male, and a male born. And lastly, we need to think about how many times we want to do this. And we bring this up because we have to remember that experimental does not always match what we think would happen in theory, right? Doing one experiment is not going to be the same as what should happen over a kind of a theoretical idea of this. But we also know that if we repeat the experiment, the more times we complete it, the closer we get to theoretical. And since we do need to do it many times to get closer and closer and closer to what we think might be true in general, we'll have to do it many times. I actually would suggest just doing it upwards of 100 times, right? So maybe, for example, do this 100 times. That's a nice large number that I think does it justice. I think that will get us enough information to make some assumptions. So this box right here that I'm making around this, these are the steps that you would need to simulate an experiment, right? So you'd make a representation, you'd run the trial, record the results, and then repeat the trial multiple times. And we don't just have to use a coin. For the exact same concept, we could also use a spinner, right? We need 2 results that are equally likely, since male and female are equally likely in this example. So we think, all right, how can I design a spinner that would represent that? So a spinner with 2 equal halves, right? One color green, one color yellow could easily represent male and female. We could assign a representation. Once we've made a representation, we can do a spinner as a trial, right? And we would have to do it 3 times to represent our 3 puppies. And once we've run our trial, right, we would record our results. Maybe say we got yellow, green, and green in our 3 attempts. And then, of course, we would have to replicate it or repeat the trial multiple times to get more information. So those are 2 ways you could do this, right? You could flip a coin, or you could set up a spinner that would represent the 2 options of the outcomes for this experiment. And this experiment we can't do in real life, so we're simulating it with either of these two options. And there are many ways that we could do this simulation. I'll just give you one more, and maybe that would be with a bag of marbles. To use a bag of marbles, we would simply need to make sure that the contents represented our two outcomes, right? It's equally likely to be male or female, so I'd put in marbles that are equally likely of two different colors. So maybe 3 green and 3 yellow, one representing the male outcome, one representing the female. And I would just go through the exact same steps that I did with my other two examples. So once again, I have my 4 steps here, right? I would pick a representation, so maybe this time green would be for female. I would then proceed to pull out a marble 3 distinct times, making sure that I put the marble back in and shake it up again before I try it again. And then of course I would record the results. Perhaps this time I get a yellow, a green, and then a green. And then I would repeat the trial perhaps 100 more times, right? So that I can get closer and closer to that theoretical probability to decide what really would be the probability of getting 3 puppies that are female in a row. All right, so that was just a little bit of information of how you might simulate an experiment that you can't actually perform. And we have lots of tools at our disposal. We can use lots of the things that we've already been using just in terms of our experiments in class already. So that was the essential question of the video, how we could design a simulation for a probability that we cannot test. And we'll practice this in class as well.